just lay down a base, and you can start our workshop. All right, so I want to talk about human input as chop data, and the most basic human interactivity in Touch Designer is just a button. And you know, like a button, when you hear the word button, you think, okay, it's just an on and off, but it could do so much more and have the user who's pressing that button really affect the visuals in a way which is not just on and off, you know what I mean? So we're going to start by just placing down a button. And the button of Touch Designer, it comes by default that it's going to on and then it's going to off, which is fine, and we're going to keep it like that for now. But really, you can do so much with just this interactivity, you know, because if we had, for example, a noise chop, which is completely generative, has nothing to do with humans, and we'll have something like a LFO, which is basically giving you some rhythm. You're all familiar with it. So moving on, I just want you to see and visualize it. So I'm going to time slice that noise by going to the Command tab and checking on time slice. So now it starts moving with time. And I'm going to change my LFO so it's going from 0 to 1 by just offsetting it by half and making the amplitude half. And that way, it's going from 0 to 1. And then we'll merge all these three, and we'll try to compare them visually by just trailing them. So the button and the trail. So here we can also rename those so we know what they are. So I see my first input, which is input 0, is channel 1, and that's the noise. So I'm going to call it noise. The LFO is the second input, which is number 1, because everything starts from 0. So we're going to name it LFO. And the button. That way we know which one we're dealing with, and we can see it visually, which is exactly what we want. Okay. So now what we can do is start making cool stuff with it. But before we just go ahead and do that, I'm going to talk about different ways we can generate progression in Touch Designer and in chop data, which is basically driving everything in Touch. By just thinking of different methods of doing it. So basically, the first one that could filter our data is a leg chop or a filter chop that could do very different things, but it's just smoothing out our signal. And then we can look at it here, and we can look at it with the filter on the trail, or we can look at all three of them and compare them. So I'm gonna plug them to all inputs like that. And then if you activate that little guy, then you can say something I do a lot to compare different data and streams of data is I right-click here and I say number of graphs, all channels in a single graph. And that way you can see the different results on top of each other. So basically, those two nodes are a very good friend of a button because a button goes from 0 to 1, right? But once you leg it, and we can isolate that by just putting a null here, for example. We can isolate the button. Actually, you know what? Let me get rid of these two and just plug one of them at a time. So let's start with the leg. The leg chop is filtering our data, and once we press that button, then suddenly you see we're not going from 0 to 1 in a split of a second. We have some nice curvature to it. So as long as this value on the right is basically determining how much time it's going to fall after we hit the button. So right now it's 0.2 seconds, but I can make it a second. And I don't want it to affect the value whatsoever, so I put here 0. And this way, we're going to press the button, and we see it's going up super fast because I have 0. But when I press down, then it takes 1 second to go all the way to 0. And that's already some progression, no? So basically, I'm going to now work with the button for a second and talk about more ways we can progress that. So we know we have the leg chop, which can give us the going down of the values, the tail of the values, and we can smooth that out very nicely. And this does the exact same thing, but for the going up value. So now it takes a second to go all the way to 1. And with the filter, it's a bit different because the filter is doing like both ends. It's filtering them, so you get more like a S shape instead of a hill, you know. And all right, so now we want to drive some stuff with our button. But first, we're going to drive it with the LFO and the noise just so you see the differences. So I'm going to put it back in the chain. And I'm going to throw down a sphere saw. 3D sphere, very easy, very simple. Sphere. Oops. Sphere. There you go. Nice. So now we have a sphere, and we can do many things with it, but for now we're just going to make it bounce based on our button or our noise or LFO. By just laying down a geometry comp, I right-click here, so it's much faster, makes the connections for you. And also inside the geometry, it puts an in and an out, so whatever you do outside gets passed to the renderer. And I'm going to open the 3D view of Touch Designer, but just clicking here, say split left, right, and here say geometry view. So we can see our sphere. And we're going to start by just hooking it up to our last node, which would be a null. Almost every time I want to export something, I put down the null. So we can change stuff later and would still affect our output. So first thing we want to test is the noise. The noise is a very key component in every visual you make, and basically it could generate motion or color or any data randomly. But I also have a lot of controls in it, the noise, that could definitely change the behavior completely, like the period of the noise, the frequency. Oh, sorry. Yeah.
How do you see that in the geometry view? How do you see that?
I just press H. H is home. Yeah, and W is wireframe. There you go. And then you can walk around stuff. No problem. So we're gonna, yeah. Yeah, do you have a question? I said, so it's just that little guy here to activate the viewer. And then you right-click here, and you say number of graphs. So usually, like, it's on 1. And then you can switch between or all channels. I don't know what it's default. But when you press all channels in a single graph, then you get them one on top of the other. All right, so here we can play with the noise parameters. And we're just going to increase the amplitude so it goes up and down like crazy. And as you can see, I mean, when I did this, when I just increased the amplitude, it went through my filter, which made that thing gradually go up and not right away. So our filter is filtering our noise. I'm going to disable it for now so you see the pure noise data. And as you can see, yeah. I just activate that little guy again, and then you can drag and drop it anywhere in Touch Designer. So you can take the noise and just pick it and drag drop it here. Usually I pick chop reference because behind the scenes what it does, it puts a Python expression here that reference that null and that channel. So actually what's better to do is to type it yourself. So up, null 1, and then in square brackets you get the channel name, so or the channel number. So it could be either noise here, or it could be could be either noise or 0, which are always referred to our first channel within that null. Okay? So when you put a name of it, you have to put the single brackets in Python, and when you put a number, it's not a string, so you can just put 0. But behind the scenes, when you drag and drop this guy onto any parameter and say chop reference, then it types it for you. But we'll get back to this after on how to reference stuff in more complex networks and in Python. And basically, we're seeing our pure noise data, and it's quite hectic. It's quite random. It's not very interesting, actually, because it lacks sensibility of just something that's beyond generative. And that way, I want to switch it to the LFO. So what I'm going to do is I'm going to write here LFO. And then we'll get like a pure sine wave going up and down. Very simple stuff, basic, between 0 and 1. But if we want to make that bigger, we can put a math chop and just multiply it by however you like. I'm going to put 10. So we'll see the LFO giving us this perfect sine wave. Now, visually, I find this more interesting than the noise because basically this has a really round curvature, and it's very pleasant to watch this, actually. But going on to but the one thing that it's missing is some variety in the timing, because it's always on a constant rhythm going up and down and up and down. So now we're going to go to our button, and we're going to switch the sphere Y position to the button. And we're going to press the button once and see that it's going up by 1 unit. And when we press it again, it goes back to 0. It's very boring. But also, it's very boring, but I'm controlling the timing right now, and not the noise or not the LFO, so I could really direct this in a way that I want to, or based on my guts and my aesthetic feeling. So we'll put the filter back on, and then you'll see that it goes up very nicely and it goes down very nicely. We can also multiply this with just putting a math chop by 10, so we'll get a bigger effect. And it goes up, and it goes down. Also, the button itself has some more options. One of them, well, I'm not sure exactly what all of them, like the radio, the exclusive down up and stuff is doing, but I know that momentarily is just gonna, I'm not gonna need to press the button twice. I'm gonna press it once and it will come up and down. So basically, if you see the signal, you just get a pulse, and then you filter it out. Okay? Now, I want to progress this sphere into in time, basically, and I want my click of the button to do something a little different each time. So basically, I'm controlling the sphere, but I want to input some generative stuff combining with it. So each of my presses is going to be unique and going to create something different. So how are we going to do it? Let's think. Basically, we can get by doing that, and we can take that math and put it into the amplitude of the noise, and then we're going to switch it back to the noise here. So I'm just going to press noise, type it, noise. And now what would happen is that I'm going to activate the noise at the current time it's at. And the amplitude is on 0, but when I press it, it would go up to 10 and then come back. All right, so there's some math that we need to take care of. So here I multiplied it by 10, which is, it's fine, but we can actually do, so I just deleted it. We can actually get rid of this noise and just clean our network a little bit here. So I'm getting rid of this and the merge. And I'm only left with a button, a rename, a filter, a trail so we can see, and a null that's exporting to this guy. And we're exporting the noise. Right now it's renaming everything to noise. But yeah, let's keep it noise. But what I want to do is I want to bring it down a new noise just because I deleted the last one, time slice it, and connect it. And I want to make sure the noise moves also from 0 to 1. So right now it's going from -1 to 1 by default. So you can see that visually here. So it goes, yeah, roughly -1 to 1. But mostly on them like -0.5. So we're going to do the same. We're going to offset it by half and make the amplitude half. And that way we're making sure that it's normalized in value. So now our sphere moves purely on the noise, but if we just increase the amplitude of this by 10 again so we can see it better, we can start, let's put the null here, and actually the filter is not related to the noise anymore, it's related to our button. So I'm going to take it out of that chain, connect it here, so we get that nice button movement that goes from 0 to 1 and it comes back. And that way, I want to influence the amplitude of our noise. So you remember this math that we multiplied by 10? We can actually multiply it by 10, but also by this number. So I'm just going to say this number times 10, which is the same as doing it in chops, right? And then when you press that button, then it would start going to the noise and immediately fade down to 0. But you can see that each time I'm pressing it, it's a little bit different. And we can make it even more crazy if we just make that number higher. And also the filter is smoothing our button to go all the way from 0 to just 0.2. And we want to have the full potential of this. So I'm gonna basically, I did a little bit of a mess here. So I'm gonna take away the filter. I'm gonna reference my null2 instead of the filter. Null2. And here I'm gonna put a lag instead of a filter. So lag. What's that? Lag. And now it's now it's very responsive. So now when I'm pressing play, I control the noise, and each time I'm pressing, it's a bit different. So we can also make the lag a bit longer, so it's nicer. And when you press it, you kind of activate that noise thing. All right, so now that's pretty boring. Let's start making it cool by basically creating the same concept as this one, but instead of moving it up and down, what we're going to do is we're going to create some instances of that sphere, and we're going to spread them apart with a click of a button. And what's interesting is that you can press that button for like a momentarily, but you can also press it for 1 second and release it. And you can also press it a few times very, very fast, or you can press it and leave it on for an hour and just, you know, so there's so many ways of interacting with just one button that we want to take advantage of. So let's do that by creating instances. So we will use our original, well, you know what, we can just leave just the button and the leg and our sphere for now. So it's a fresh scene and everybody would be on the same page, right? Cool. So now we're going to create another noise that has by default 600 samples. So when you middle click on this, you see the information of the node. And that's a lot. So I'm going to go into channel, into the channel page of the noise and switch it from seconds to samples, because I want to know the absolute number of samples I'm going to have in that noise. And we're going to start with 10. Here we're going to create 3 channels of noise. So we're going to do TX, TY, TZ. And we're going to make a null here at the end and export that into our instancing tab. So I have to turn it on and drag my chop null into the chop sop that whatever you want you can put here and it would create instances. So I'm dropping it on and then assigning the TX, TY, TZ to my instances. So now we have 10 spheres here. They're all being driven by this noise. And the noise is very small. You can play around with it. You can like change the period to get different aesthetics and shapes. But what we want to do is we want to increase that amplitude and turn it down back again. So I'm just going to reference my null into the amplitude here. And then by clicking the button, we can see we start to get some motion. And it really depends on how long I'm pressing that button to get that. So one thing we could do is multiply the effect so it's more major, it's bigger. There you go. And we can play with the noise period to make it more interesting a little bit. There you go. So that you have to assign the tx, ty, tz, and you have to have 10 samples in your noise. Got it? Cool. So now we can really like start driving the visuals by a simple button. And now we want to do something before we go ahead and make it look nice, which is the cool part, but really it's not the essence of this workshop. We want to know more things about the human pressing that button. So we want to know when he's releasing it, and we want to change stuff based on how many times he clicked, for example, or any other idea you might have to apply that button interactivity to the visuals. So basically what I want to do is I want to detect when the button is being pressed down, when I'm releasing it, and I want to trigger an event at that point of time. Okay? So what we're going to do is we're going to make a trigger here after the button. And trigger has two options. It's either triggering when you go from 0 to 1, which says increasing values. So it would know, like, it would reach 1 by just going from the lower number. Or it could do the opposite by just triggering when values go down. Okay? So I'm going to change it to decreasing values. Also, some stuff I don't need here is the attack. So I'm going to take it out. And the sustain, I'm going to like zero out all these things. So we get a smooth trigger by just releasing it. Hold on. Oh, okay. So we need to have the trigger threshold to be 1. But if it would be like 1 as an integer, we will never hit it. So I'm just going to put like a .99 here. And that way, when we press it, we have nothing in the trigger. But when we release it, tuck, we get a trigger. And this is one of the ways we can start like building more and more complex interactivities just on one single button, right? And then we want to determine how long it's going to trigger for this thing. So right now it's a 1/10 of a second. So actually it's pretty good. Let's leave it that way. And what is it going to do, this trigger? So I wanted to just, well, in the noise tab, we have a transform, which offsets the noise. And basically, I want to offset the noise based on that trigger. So I'm going to put another null here. And I want to leg it as well, because I want it to be smooth out a little bit. And I want to leg it only, or let's leave it like that for now. But if we throw that on the offset of Z of the noise, or it could be any one of these, actually, then what you'll get is going up, everything was same. And when I release down, you saw that little thing there that happened. So if we want to make it more major, we'll just put a math and just multiply it. And now you'll see it more clearly. So when I release it, the noise changes and creates that trigger effect. All right, and this is starting to get better, but it's not there yet. I really want the user that presses that button to feel like a huge impact when he releases it. So basically what we could do here is instead of thinking about the noise offset as a value that's constant and it's changing from 0 to whatever and back to 0, we can start thinking about noise as an endless offset. I'm going to put down a speed chop. And speed is just measuring the value. And if it's big, it goes up. If it's not changing at all, it would just stay at the same value. And it would kind of keep accumulating until you pulse it. So that number is going to get bigger and bigger and bigger. And that way, every time I release it, it's gonna change differently. So we can, hold on, let me see. Yeah, so it's happening, but it's very, very subtle. So I'm going to put another math here and just multiply it by 100 or by 10 so we can really see that effect. There you go. That's too much. So let's try 10. Nice. So by just having one button, we created this interactivity, and now we want to make it look a bit more interesting. And see how, like, when I press the button for 3 seconds, then it looks like this, and then I release it, it comes back. But when I press it again, it's completely different, right? So this is how you can start progressing the animations and the interactivities based on your human input.
How do you set up the trigger?
The trigger, it's so attack and sustain is all 0, and the trigger itself is on. It's triggering when it hits 0.99.
Attack is everything on 0.
Yeah, attack is on 0, except of peak length.
Peak length is
Yeah.
0.1.
Yeah, that's the duration it's gonna trigger for. So 0.1 is good. But if it was on like 1 second, so you saw that reaction, it would just keep on going for 1 complete second. So I want it just to be 1/10 of a second. So we get the impact, and that's it. You got it? And decreasing?
The sustain is?
Sustain is all zeroed out. And here you have to do,
0.09.
yeah, decreasing.
Decrease, sorry.
Yeah. All right, cool. So let's get to evolving it even more. So basically, I want this stuff. For example, like we can take that logic and we can reverse it. We can say, okay, I want stuff to happen when someone is not pressing the button. All right, and when he does press it, it would stop happening. For example, so. Here, I'm going to use a logic. Yeah. Sure. Yeah. So on my transform, I reference the trigger chain now. And here, it really depends on you. You can play around with this. You can change different noise types, and you'll get like a complete different look with each of these. And the period, obviously, you know. All right. So now we want to do some stuff to it when someone's not pressing it. So we're going to use Logic Chop. Logic is a good friend of yours if you're not doing a lot of code, because it's basically like a if then else statement under the hood. And it does turn on when we press the button, and it turns off when we release it. So we want the reverse logic. So we're just going to put a math here. And I'm going to range and just saying instead of 0 to 1 to 0 to 1, I want it to 0 to 1 to 1 to 0. And that way it's 1 when we're not pressing it, and it's 0 when we're pressing it. And again, we can use the lag chop here to just filter our signal a little bit. And let me think what this thing's going to do. This thing is going to change. It's going to change the colors of those spheres. So in order to do that, what I'm going to do is I'm going to use the same noise, because it's normalized, it goes from 0 to 1. And I'm going to add just 3 more channels, which is RGB. And that way my noise is generating RGB values. Let me think. And once we press it, then it would generate the RGB values, but we need to assign them here to our instances. So I'm going to the second instance input tab. And here on RGB, it can actually take the values from the chop and apply it to our spheres. So if I put RGB here, then now our spheres are black. But when we press it, it's going to get some more values here. And actually, when we're not pressing this, all the noise is zeroing out to 0, which is it's cool. But I just want some motion there when you're not pressing it. So it would be like a live piece, and when you press it, you just like amplify it. So here we can the amplitude goes to 0, and we can just like add a small number to it. So it doesn't go all the way to 0, it just stays on 1 or on 5, for example. There you go. And we want to change the colors, so we need to offset our noise. But because we're using the same noise for RGB and T, X, Y, Z, then we have to separate them out. So let me take those out, sorry, and put another chop. We can actually copy-paste this one and just call it RGB. Then we can merge these together. So we can control them separately, but we can output them together. There you go. And now I'm going to use speed chop again here with the math. Just copy paste those and put a null here. So we can offset our noise in the transform tab, but not from this null, but from the other one. So you do that. And that way it's changing when we're not pressing the button, and when we do press the button, the color kind of stays the same because the offset is now on the same value. And you can see it very visually if you trail these two nulls that we're outputting. Like you can see, like basically trail chop is your eyes, because without it you don't see what you're doing. But you see now that this value goes up and changing our color. But once we, let me just take that out. So once we press that button, it stops. It just like flattens out. All right. So it's getting better. It's a bit too fast for me. So I'm going to, I think I have one math here that's on 10. So I'm just going to make it 1 or 2. So it changes a bit slower. Cool. Also, another thing we could do is change the sizes of these guys. So we can, basically we have like a noise for translation, a noise for changing color, and now we're going to add another noise that's going to deal with their scale. So here we don't need 3 channels, we only need 1, and we're going to call it p-scale, like point scale. And this guy is going to go into our merge, so we can output everything together. All right, so p-scale should be assigned to the first instance tab on the geometry comp. Just scale x, y, z. You can give all 3 of them p-scale. P-scale, p-scale, and p-scale. And now this is acting kind of funny. With that logic chop that we did that we wanted to happen when we're not pressing the button, but now we want it to happen when we do press the button. So you remember that math chop that we did 0 to 1, 1 to 0? We're just going to get rid of it. And then it's not going to change scales at all unless you press it. And then it would start changing scales. This one goes really, really big, as you can see. And that's because our amplitude is very high. So I'm going to get rid of that 5 that I added. Oh, sorry. And then our scales are on 0, so we have to have like some offset here. So let's say 1 would be a good. And we're going to make sure that we don't go all the way to 10. So actually, actually, we don't need the speed chop here. And the math is on 2, which is a lot. Get rid of that. And I find that too big, so I'm just going to multiply it by half or by a small number. Just, you know, to, hold on. P-scale. This is referencing null 2. Oh, it's that one. Okay, so because I copy-paste that noise, it came with my old settings. So I'm just going to set to output from null 4. All right. And now you can see the effect. Like when you're not changing, pressing the button, they all stay the same size. But when you do, they start like growing and shrinking a little bit. There you go. Anyone has any questions so far? All good?
Sorry.
Yeah.
Which chop is being referenced in the geometry for the instance?
So basically, when you output to instance, you output all of them together. It's the merge into a null, and that way you know that this guy is referencing all the data he needs from here. Cool. So we can make that effect a bit more. So 0.2 was low. Let's try 5. And also, those decisions that I'm making are like, you know, based on eye and aesthetics. So it could be different to any one of you, and please make it different. Don't use the same values that I use. All right, I'll try to make things bigger. Yeah, and also arrange my network. Sorry, I'm super messy today. So I guess that makes more sense. Like the button is driving all these legs and math and speed chops, and that gets outputted to the noise, 3 noises. One is for position, one's for color, one's for scale, and all these guys are going to the instance of the geometry. Yeah? Yeah, that's it. There's no more than this. You have a specific question?
Can I ask what, you missed me on the point of the logic.
Logic?
Isn't that what the button's doing anyway?
Well, yes, but no, because button could be momentarily, or it could be like radio up, down. And well, the logic is kind of, you know, that if we replace that thing with an LFO, for example, then the logic knows when it's not on 0. Yeah, it's kind of the same thing, but I like using logic to do the exact opposite, you know, of what the button does.
And the logic is in a reference to what in the, what's it, noise?
Yeah.
Scale noise?
Yeah. So this one goes to the noise, here, the amplitude. But yeah, you know what? Now that I'm thinking about it, we can easily like, get rid of it. And it would do the same. But, you know, it's just like keeping your thought process as well, so you can create some logic that, you know, I want to do something when the person is not pressing it. So that's the logic, you know, basically. All right. And now we just wanna make it look nicer. So sorry. If I like this, small. That okay. That was on 1, and my noise here had an offset on 5, so put it to 2. Okay. So I kind of want them to stay close together, because what we're going to do now is just going to try and render it so it looks like a Metaball, but it's not. So let's put down a render top. And a camera. And material, which is going to be constant for now. And assign the material to our geometry. So we can see it here. Let me just zoom out a little bit, like that. Perfect. And now we can switch that thing. Instead of geometry viewer, we want to see it here on the side. So panel or top viewer. And we're seeing it, but I don't want to see it in the backdrop, so I'm clicking here and I say display off backdrop. Thank you. Oops, sorry. And now that we have it rendered out, we want it to look more like Metaballs. So I'm just going to zoom up a bit more so it doesn't go out of my frame at all. And I'm going to do a trick, which is just to blur this out. Blur this out by quite a lot, like 50. But then also something that you should know about the blur top is that it has a ratio of how it's blurring it. So if you middle click on it, you see that the ratio is like 1.77 to 1. And that means that if you look closer on the blur, you see that it's kind of blurring it horizontally more than vertically. So if you put the same ratio you have of the pixels here, which is 1 to 1.77, then the blur becomes perfectly round. And that's something, you know, that you should just keep in mind. And then what we could do is we can threshold this thing out. So we get like a continuous edge. Continuous edge. You can like a bit shrink it down so it's not entirely outside of these, but it's kind of inside. And then we can just say inside, just like by simple comp stuff. So this inside that. Hold on. No, sorry. Like how I did it here. Inside. So basically, we need our render to look like a Metaball. So if we just put that, it looks like a Metaball. But if we want some colors, then we're going to use Dilate, but that's a bit heavy. So we're gonna just blur it out less, I guess, like 40, and threshold it and when it's a bit smaller. So this is smaller than this, and if we do the inside now, Oh, sorry, the other way around. Then you can see already that it's starting to blend together. When you press that button, it's almost looking like metaballs, just by doing that trick and threshold trick. And of course, here you can do a lot of stuff like distort stuff based on this. So I wanted to make it look more 3D and stuff. So what I can do is I can make my spheres a bit bigger in the P scale, so we can offset it.
How's the inside working?
What?
How's the inside?
So basically, it's your blurred version of the render inside the threshold that you did based on that blur. Okay? And we can make that the spheres are a bit bigger, so they blend better. And now our colors are actually making these holes too, which might be good, might be not good, depends on what you like. But I'm just going to make the threshold, so it's so I'm going to put like a HSV adjust, and I'm going to take down the saturation to 0, and that way it's monochrome, so our threshold always going to be like in the shape of a sphere, and if it's blue, then it's going to take into account also the blues and stuff. All right, and now we can really you know, advance it a bit more by basically what I want to do is I want to have some surrounding for this little metal ball thing that we made, and I want to distort this as if it was like almost like glass in 3D, just to make it look nicer. So how I'm going to do it is I'm going to create a text top, and I'm going to drop it here. I'm going to make it 720p because that's the resolution we've been working with. And I'm going to type here something like and there's one setting here called word wrap, does this. And this is just going to go over our sorry, yeah, so this is going to go over our thing. Awesome. And now we want to affect it in a way. So one really cool thing that is recently been adding to Touch is the ability to render passes. I'm not sure if you guys are familiar with it. But if you do, it's a great way of getting 3D data from the renderer and using it in post-process. So how we're going to do it is just by checking here. Let's see. All right, so it's not by default in constant material. So let's switch that to a Phong. But then we will need some light as well, because Fongs have to have light. So I'm going to add a light. I'm going to add a light, and I don't know, let's take it up a little bit. There you go. And it's cool because it also affects our metaball field. So now, like, also the light is being affected. So you see, it's only like the top parts. So actually, what I want to do is I want to add some emission to it, or constant, because constant is going to use our colors. There you go. And that way, how it looks from the render, it doesn't really affect by light, maybe just a little bit. just a little bit. Cool. And now you can see that you have in the Advanced tab of the Phong or a PBR material, you have all these color buffers options now that could let you output stuff like normal maps, point color, texture coordinates, if you want the UV pass, if you want the specular map, all the maps that you can apply to that material basically. And you can render them separately. You have like one beauty pass and one normal map. And that way we're gonna displace this text a little bit. So I'm gonna use camera space normal, which means it's just the normal the camera sees of those objects. And I'm going to make a render select, which this node is going to let us use our pass in the second buffer. And I'm going to allow this to happen by going to the render and going to advance and say color buffer 2, not 1. So now this render has 2 color buffers, and one of them is our normal map. Or not map, it's actual the 3D normals for those spheres. And we get this, which is our normals. And now, if this was to live in within this space, then it would kind of wrap around like a glass ball, the text. So I can just put a displace top. And connect my text to it. And I can connect my normals here. And that way, I mean, I know that all the values around here are 0. So usually normal maps are like normalized to 0.5. But in this case, we're just going to use it as a source midpoint 0. Cool. And probably the amplitude is way too big because we kind of, it disappears here. So let's shrink it down to a really small value, like 0.02. See? And red, green would be our coordinates. Yeah, this doesn't matter much. Let's see. Yeah. So now what happens is if we lay this over, it's almost like we're creating this refraction effect for the text being displaced by these guys. And the more you see. Oh, okay. So the math here is wrong because we're rendering 8 bits, and normal maps have to have like negative values. So you have to switch that to a 32-bit float by going to Comment tab. Oh, sorry. So it has to be on the render itself. Comment tab, and instead of 8-bit pixel format, we're going to 32-bit pixel format. And that way, our color values are not normalized between 0 and 1. We can have more data there, negative data, and also very high data that we'll see as white, but there's actual numbers there. So now that it's on 32-bit, you can see that the text is a bit rounder. Really squished. So you have the source midpoint on 0 or on 0.5? 0. And the weight has to be like super, yeah, I mean, it does what you expect it to do, and you can control like the amount it does it. Okay, cool. Yeah. Okay, so you have to go to the render itself, and under Advanced tab, you have to increase the number of buffers it's rendering. So it's kind of like the render passes. If you want more, it's going to be more heavy, but you'll get more controls after.
Just put normal map underneath the font. Is that
Yeah, so in the shaders, you actually, so you can have like multiple objects, and each shader would output to whatever buffer, whatever you want. So you can really start making complex render scenes like that. And for example, you can render like emission as a separate render pass, and then apply some bloom on it, while the beauty part doesn't have bloom. So it's very useful. I'm very thankful to the RevDiv that they included this stuff just right out of the box. So yeah, you got that working? Nice. So now it's supposed to do this. Let me see why it's not. It's 32 bits. We get the displays chop. Maybe it's supposed to be on 0.5. Nope. Green. Blue maybe. Oh. So basically that's our normals. GP. So blue is our Z component, which doesn't really take effect because we're doing 2D stuff right now. But this should definitely displace these guys like nicer. Let's see. Yeah, it's almost like a simple refraction effect. But the cool thing about this is that you can come here and blur this out, the normal map, again with those ratios that I was talking about. Just make it big, and then you start like blending the normals. So instead of being so sharp, it's now looking like a liquid displacement or like a refraction effect that's happening in post-process. All right. And I think that now I'm going to move on to, like we can take like a 5-minute break, and then we're going to move on to some VR controllers and some light stuff that's going to happen with more sophisticated input than just one button. Yeah. All right. So this was cool, creating one button, which is the most simple way to interact with humans in Touch Designer. Now we're moving on to some sliders, and I'm going to show like a simple setup sliders and how we can use sliders, and also how we can make sliders add some human interactivity. So I'm gonna create this super simple 3D scene so we can render it by just placing a grid, placing a tube, and placing a box. There you go. All three are here, and then we're going back to our geometry view here, and we can. So what I did is I put this button stuff that we did in a container, and I went out and I put another base that we're gonna work on right now. So here, if you can see, like this is the hierarchy of what we're looking at. So if I'm going up, to sliders, then we're going to see sliders. And if we press the blue flags, then it means it's going to display in this thing, in the geometry shader, geometry viewer. You know, the other flags are renderable and whatnot. So let's just make the grid so it's a floor almost, and just make it bigger. Let's take that tube and go to detail tab, say add cups, so it has some cups. And also what I want to do is make its radius 0 on the tip, so it looks like a cone. There you go, cone. And then we can just like move them apart a little bit, make the box a bit bigger. You know, you can do it to your own flavor. And cool. Now we want to render those, so I'm gonna throw down geometry comp, but if I do it actually not by tabbing, I'm doing it right click on the thing, so it does it for us, and it's much easier and nicer. So I'm gonna call this floor. I'm gonna call this cone, and I'm gonna call this box. Cool. Here there's a lot of tools from Touch Designer, derivative, that are awesome, and one of the best ones, if not the, is the Arcball camera. It kind of let us view the same thing here that we have, but with a render. So we're gonna use this as our camera. So I'm gonna show you how to like quickly wire this. So just put down the render, throw the Arcball camera. I'm just copying pasting that name, Arcball camera, into our cameras. So Arcball camera dash cam1. And then I'm going to render it at full HD. And we're gonna put a null here after the render, so we can reference it back to this Arcball camera panel. Let me know if you want to slow down. And I'm just in the look of the Arcball camera. Right now it's set to inside background, which is what we're seeing here. So we can set it to the end of our chain, so we can actually see the stuff. Also, it's very dark here, so I'm gonna add a light. The first light we're gonna add is this one. And instead of looking at the 3D as a geometry view, I'm gonna look at panel and throw here my Arcball camera. And what happened is now we can basically do the same thing we've done, but with the actual render, moving the camera.
What did you do for the last step?
For what?
What did you do for the last step?
Last step was to go to the Arcball camera, to the look tab, and throw down the end of your render chain to the background top. And then this here, you change it to panel.
Okay.
And you have to see that on top you're looking at the Arcball camera panel, which is this.
Okay.
How do you get, where's the Arcball camera?
It's in the palette. So you see that little icon there? It's right there, and it's under tools. Yeah. There you go. So that's exactly this. All right. Yeah, dash cam1. And now, our light is what we're gonna animate. And what I want to do here is I want to use, so basically I put my light a bit upwards from my 3D scene. And what I want to do here is show you different ways of just turning the light on. And the first one would be basically by using a button again and putting down null. And then we can hook up our null to the light intensity of the dimmer. And that way we can just turn on the light, right? Cool. And then we want another light. Let's put it a bit somewhere else so it's not in the same position as the other light. And what we're gonna do is gonna create a slider. And hook that up into a null. And also, I mean, you'll see that the slider goes from 0 to 1, which is perfect. And we'll just link that to the dimmer instead of our button. So now we have like one light that we can turn off and one light that we can dim out with the slider. All right. But what if we want the light to turn on like a neon? And that way we can use noise. We could definitely use noise to do that. So I'm gonna do it with noise, just by taking that button light that we have. We're gonna work on the first light. So this guy would trigger some noisy effect until it's up. So the way to do it would be, a trigger. So when we press the button, we get a trigger. And again, I don't want any of the sustain stuff. And the attack. The attack is fine. Let's leave the attack. And then what we want to do is when it goes from 0 to 1, we want it to add some noisy, stuttery motion to it. So I'm gonna lay down a noise again and just time slice it. Make it go from 0 to 1, so offset it by 0.5 and make the amplitude 0.5. And I mean, the first thing you can see is that we'll need it to stutter, so that's, sorry, I'm gonna put a trail just so we see it. So we want much more stuttery motion, and that's what happens if we take down the period. You get this stuttery noise now. Now I wanna have that noise, but only when the trigger turns on. So we're gonna link the trigger to the amplitude of that noise, and then we'll get some stuttering when we turn on the light. All right. And then it goes back to 0.5, and that's no good. Oh, actually, it's fine. Let's keep it at 0.5 because that's the offset. But what we're gonna do is just gonna put a math chop and multiply these guys together. So put them both together and say combine chops multiply. And now the noise is kind of on, but you can start seeing those stutters when you turn on the light. So let's see. Oh, actually, there's an error. I have an error. And that's quite common because basically I merged these two together, but this channel name was V1 before I merged them, and now it's changed to Chan1. So my reference is actually looking for V1 still. So we're going to change it to Chan1, or we could just rename it back to V1, or we can like swap these connections, and then we'd stay V1 because the mask chop is taking the name of that channel from the first input. So now when we turn it on, we get some stutter. Awesome. But what if we want to make that stutter more interesting and less noisy? So what we can do actually, which is a bit, it's a bit like of it's like just a way to show you how you can use sliders and your input to affect stuff in your scene. So if you have like a complete, you know, like a really nice scene you're rendering and you want to add a motion to it, which is should have some characteristic. So it's not a computer doing it. You want it to actually feel nice or some sort of characteristic. Then you can record yourself doing stuff in Touch Designer and use that later on. So I'm just going to take those light example and basically show you how you can record a slider to make those stutters. So this slider is going to from 0 to 1. And if you put a trail chop, it's my eyes, then I'm seeing what I'm doing. I'm going 0 to 1, 0 to 1. Cool. But if we put a record chop, then you know how like the trail chop is always it keeps counting all the time, while the record chop is actually letting you record. So what I like to do is I like to create a button that's radio up and down, toggle up and down, and if I go inside I can say, I could just call it record or rec. And then this button is will start our recording and stop our recording as well. So the parameters here, you have record. You just throw that button on it as a chop reference. And then when you press record, it does record your input. And when you press it again, it stops recording. So that way you can really start recording yourself doing all kinds of stuff in Touch Designer and then using your motion and your input to drive other things, or even you know, multiplying and varying your motion. So what I'm gonna do, which is a bit funny, is I'm gonna record myself doing the stutters. So let's start the recording. Hold on. Oh, we have 600 samples, which is a lot for a stutter. So I'm gonna make the record. Full range. Let's see. Segment 1 second, and then see. Oh, nope. Frame. All right, let's leave it full range. Yeah, for some reason now it went into 60 samples only, which is 1 second. But if you change that, I don't know, to 3 seconds under segmentation, then you go back to full range, then, hold on. Oh, okay, sorry, I'm confused. So basically the record will record how many samples you give it. So if it's resetted, then it only has 1 sample. But when you only 1 sample. But when you start recording, then it starts adding more and more samples to your record. And that's where I got it wrong. So that's cool. We can reset it. And then I'm going to try to record myself doing this. So I'm pressing on, and I'm doing something like this and off. And now I have my own motion here, which is a bit more interesting than noise because I did it. And to use that, instead of our stutter button or slider, we can now basically go through this timeline however we want. So what I'm going to do is I'm going to say resample. Okay. And I'm going to turn time slice off. And what we want to do is we want to give it a new rate and a new number of samples. So we're just going to put it on new rate, new interval. And here we're going to put absolute. Absolute and samples, samples. And that way we can see all the data that I recorded sample by sample, just going through my animation, but oh, it's on resample. Should be clip or limit. Sorry guys. It should be, yeah, resample. Again, I'm doing this time slice off, new rate, new interval, relative to start and end. And then we can chop off. We can chop off this ending. Oh no, it's resampling. Oh. All right, we're just gonna use it as is. And we can instead of using the resample, we'll just use a limit. No, it's not good. What did I? Well, if you use time slice, then this thing's gonna go over my animation, and as you can see, like it would go over this with loops. Basically, like this is related to our timeline, so it actually does my animation, but based on my timeline. Which is not so good because I want to control when it's gonna do it. So time slice node is no good for me. What I want to do is I want to what's it called? Lookup. That's right. Awesome. Thank you. And now the slider could be our lookup point. Right, so we can go through my animation 0 to 1 and see all these stutters that I made here. It should be the other way around. Sorry. Yeah. So you can see now. Okay, so now the slider is kind of going in time on that animation that I recorded. So 0 it's here, and then 1 it's here. So this would do it, you know, and basically if you hook this up here, then your slider becomes my animation, and you control how fast you want to do it. You can also have that button do the same thing exactly, and not a slider, by just legging out a button and hook it up here to the lookup. Cool. And this is kind of more interesting than our original noise stutter, because you can definitely control it, and you can go like to a really complex animation and start making lights go up and down based on your recordings. Which brings me to the next topic. And I wish I had this model. But so we built this scene, which is awesome. I'm just gonna duplicate it so you have it later on. But I'm going to call this VR lights. And I'm going to get rid of all this stuff and just leave 2 lights here with no references at the dimmer. So we start with the same scene, 2 lights, sorry. And just watch that here on the panel, we're still looking at sliders, which I copy paste and I called it VR. So now it should be VR lights. VR lights, 2020, HD, and stretch, was it stretching? Oh, there you go. All right, so we have our scene. So what I'm gonna do is, oh, actually, I don't know if I'm connected to the network, but I wanted to stream these to you, to all of you guys, so you can use them. But I'm not sure about the network stuff here. Seems like it's not even connected. So I'll have to do it myself. But anyways, what I want to do is I want to put down an Oculus Rift chop and reference my controller, left controller, for example. So that's the left one, yeah. FPS should be 90. So now left controller. Come on, work. Okay, that would be a 90. And include the buttons. It's gonna be very hard to do this. Okay, yeah. All right. There you go. All right, so now I got some more interesting data as a VR controller. It could be anything. It could be like a Leap Motion or a Kinect. But this one is kind of interesting for lights because, for example, if I turn off the second light and I only use the first one, what I can do here is I can definitely make the light move and rotate as my hand. So you get the X form, which is going to be TX, TY, TZ. And you get the rotations as well. Okay, and now we are related to this space and the tracker, so we kind of need to move the light a bit more up so we can see stuff. So what I do is I put just a null comp and move it up. And oh. All right, and now we have a point light, and it doesn't really make much difference when I move it around. But if I put a cone light, then one of these angles, yeah, there you go. Then we're really starting to light our scene based on our movements, which makes the whole difference. If you ask me, I mean, I have this amazing model from British History Museum. They have a lot of like scans for free, and you can take one of their statues and really hold with your hand like two lights, two spotlights. And also what I like to do, which doesn't work here at this moment, is like one of these buttons that I'm pressing. It should come up here, but it doesn't at this moment. This would control the cone angle, which actually makes the light open up like that. So you can really start directing your light motion as a as a as a like in this mini universe, and you can also display this in your VR set. So basically I can have like the tube here, the sphere, and this, and two lights in my hand that also can cast shadow. So if I turn on the shadows and increase that a little bit, you see it's casting shadow as well. And I can really start recording myself, same way as we recorded that slider. We can record this data, right, that comes in. And we can really start choreography the lighting and the light movements of that 3D scene. More than that, you can create like interesting shadow effects by doing that. And I have some examples to show you, but this is basically what I wanted to ended up showing you, that you can really record yourself doing this type of stuff and then use it in your scenes, which it really feels like someone is lighting it and it's not just a noise, so that's very, you can almost feel like the personality of the lighter.
So you can just with that one record piece, like the record button, flashlight around.
Yeah, do your choreography,
Stop, and then
hit stop, and now you have it. And any trigger could do that. Yeah, man.
To jump back into your recording to like punch a section, or like say you like record a section.
I see what you mean. To punch in. Yeah, I think there is a way. Let me check. Record. Well, basically you have the join, the join chop. So you can always, the node I was looking before was trim. So you can definitely take a recording of yourself. So now I'm recording all the data. And I'm moving around, I'm creating my motion, which is not amazing at this moment. But now I want to punch in this so I can trim it and join it back together. And that would be the way to punch in some stuff. Just like breaking it apart and merging it back together. All right. And the next topic I want to do is the VR bullet stuff. But we can take another 5-minute break if you want, or you feel like continuing. What do you say?
Okay.
Yeah, continue. Okay, cool. All right, so same as doing the light stuff with the VR, we can really hold physical objects and do some simulation with them. It's gonna be really hard for me to do it. All right, so let's move on from this, which I hope everyone understood the potential of this and how you can use it not only with VR controller, you can do it with any sensor like a Leap Motion or a Kinect and stuff. But I was supposed to show you now how to hold the two spheres with bullet chop and kind of throw them around. But because this VR is not working properly and such a small space, so I'm going to move on to the next topic, And the next topic is going to be humans as pixel data, because until now we just handled numbers, and now we're going to handle some motion from camera.
Like your first example?
Exactly. Yeah. Going back to this. So I'm going to lay down this and call it a mirror example. Sorry. But I do need a webcam, so do I have one? No. Let me think. Just missing a webcam. But okay, let's just move. Let's just put a movie file in. Yeah, all of you have laptops, so you can put a video device in and choose your webcam. And I'm gonna use this for now. So basically what we're trying to do here is to create some demo of an interactive installation, and everything that comes in from here in pixel data is going to affect it. So right now I have video file in and null, and what we could do is we could make a grid. Let's close this one. Thanks. Did you say no? Okay. Cool. So basically, we want to start doing the same stuff that we've been doing, just instancing this on a grid. So I'm gonna throw a geometry comp with a box and instance a bunch of boxes onto a grid. So P0, P1, P2. And I'm going to watch it with my geometry viewer. So we have a lot of cubes here. Let's make them a bit smaller. There you go. Cool. All right. And what we need to do is to somehow relate that movie with this. Basically, we know our resolution is 16 by 9. So let's make this thing also at that aspect ratio, which would be 1.77 to this. And that could be 1 and 17. Oh no. 17 and 10. So basically what we want to do is we want to relate some of this video data to our 3D data. So we can resize this by using resolution to half or a quarter even. So get 160 by 90, and that's exactly what we're going to put here in the rows. One way of doing it is just put 160 and 90, but we can do it through Python, and that way it's always referring there. It's much better. So I'm gonna look for a top called res1. And I'm going to look at is width, which is it's like this is a module of Python in Touch Designer called width. So if you go in the wiki, you can see all the different commands you can use here. You can use here like samples and stuff like that, but this is what we want. And here we're going to use height. Oops. Oops. Am I misspelling it? Height? Oh. How do you write height? Okay. There you go. Nice. And then let's our box a bit smaller and a bit longer. So it's something like this. And here, what we could do basically is to instead of outputting SOPs, we can output chops as we did before. So we need to convert the two data prototypes. So we do SOP to chop, SOP to chop, and we reference this thing, and then this become our instancer just by putting a null, and take that here. And now we'll have to switch the names to tx, ty, tz. And now what we want to do is we want to start creating some colors for this. So one cool thing could be because we're dealing with these resolutions and they're kind of fine. Like when you get to bigger resolutions, you have to start going to GLSL for this. But what I'm gonna do is I'm just gonna convert the picture into chop data as well. So we're doing top to chop to convert that image into an RGB format that has 160 samples, and it has an RGBA, which we don't need the alpha at the moment. So I'm just gonna get rid of the alpha. And now what we're getting is just one row, like the first row of that video. So we need to say full image, and that way we get the RGB values for all that picture. And we need to basically shuffle this thing so we get all the RGB data in one channel. So we say sequence channel by name, and then we get 90 times 160, which is exactly our number of instances in RGB data. And if we're right, then these two should have the same amount of samples. So the top two chop and the top two chop from the image should have the same amount of samples, otherwise it won't work. And once we have that data, we can just merge it in here into our stuff and reference our color as RGB. Now as you can see, it's all messed up. And that's because the way this top two chop is working, where it does like one row. Yeah.
What do you set up the top two, put it in full image crop, right?
Yeah,
What else did you set?
that's it. That's it. Full image crop, and I took off the alpha because we don't need it. So basically, what we're trying to do is to correlate these numbers with our pixel data. So we could do it in a different way actually, where let's get rid of that for a second and just use a material to do that. So we can use a constant, for example, and put it here. And then you see we won't get anything anything here, because basically we need to correlate the pixels to the instance numbers, and we can do that by either writing a small GLSL shader, or we can pass on the UV attribute to our textures, so they get the UV by going to the SOP2 and turning on UV, texture UV. And then here at the UV, you just reference, hold on. Oh, so we have no UV. Oh, we do have UV. Okay. Okay, so something I'm doing, which is a bit of a hack, is like I take the UV in point. So I put a point SOP to add UVs. And then this guy should be input normal. See, should be like UV tax. I don't know. No. How would you do it? X. So here. Oh, there you go. Okay, so we have a keep texture. We're just going to do an add texture. And that way we have the UV as point attributes. And this way we can really get it into chop data here. And we're going to pass it on to the shader by just giving it the U and the V. And it looks the other way around. But that's fine, because we can change that. So that would be, sorry, that would be this. I'm just like flipping it over. This would be height, and that would be width. Height. There you go. All right, and now we want to detect some motion that's happening in our video or in our webcam. And we can do that by using optical flow. If you're not familiar with optical flow, please tell me now so I can explain it.
I'm not.
You're not? So basically optical flow, I can throw that in. It's a way of calculating vectors from pixels. So it calculates which pixels move in what direction, and it gives you that velocity map. So if you go to Tool and you drop down the optical flow here, and we can actually work on the low res stuff, the res down, then we can get those. We get those movement data here. And that would be you if you're with the webcam. And basically the stuff we want to do with the movement could be anything. Could be like affecting the color, the size, the rotation of those instances. So in order to do that, we need, see. That. just gonna try something real quick because I'm not sure how I've done this. So this is it, and then I want to shuffle by okay. So it's a bit of a workaround, but in order to match these like I've tried to do before here, we can do something like this, like take the full image, R values, only the red values, and because what happens now is all the pixels are here, and we need it to be per row, so it's a per row thing right now. And if we want to arrange that, we just need to shuffle it by it's like split sequence all samples. And then put here 160. And then shuffle it by name. I'm going to try this out. And let's see if this gives us anything good. So R. And just put that in. So so I'm gonna get rid of the texture for a second and trying to work out this mess here. So basically we have all the red channels, and we can sequence all samples, split. We can do sequence all samples, but then it's per row. And I think it's on full image. Yeah, it's on full image. What if we put it on pixels and we shuffle? Oh, there you go. So all we needed to do is switch that to pixels and not to 0 and 1, because 0 and 1 is the UVs, it's not the pixels. And the way it's organized is just by pixels. So now we have that data. So we basically are going to use the optical flow to drive our stuff. So what I've done is I did the shuffle by name, so we can have the red channel and the green channel together, being converted to 2 channels here. And this is what's going to drive our scale and rotations. So I'm going to put back the texture that we had. So let's put that texture on. There you go. And then let's get rid of that R that I've put there. Okay, cool. So we want to do some stuff with this. And right now it's like it's giving us all these changes in the frame. So I'm just gonna filter it a little bit, like do some lag or filter. And I can do a filter per sample, so the data is less jumpy. Then what I want to do is I want to turn it from 0 to like -1 to 1. I want to do it for rotations. So I would do something like -360 to 360 and apply this stuff, which is the RNG. We can rename that actually to R rotation X and rotation Y. And we're going to apply that in rotation. Why? And that way, only when where the video changes, we're getting some rotations. So if I'm changing that video, let's do something a bit more. There you go. Then you can see that where the plants are moving, we're getting some rotations. But where there's none, we're not. So why? Let's try this here. And so I'm gonna do the RY on the RY and RX also. But then we could do also something like apply this to the scale. So scale Y would be RX. Oh, it's huge. So let's just duplicate that and call it scale. So scale Y and scale X. And then here we can just reference that in scale Y. I just want to add that to my chain. And have this being affected by scale Y. So that's huge because I did the 360. But now you can see that where there's motion, we're starting to drive our 3D geometry all in the shader and all in instances. And also because I changed the video, so now we're actually double the amount of instances, so it's a bit heavy. So let's do 8 of it. Now it runs nicely. And also, I mean, we're looking at it in 3D, so that takes a bit of performance. So if we render it, it would be even faster than watching it here. And I wish there was a video of a person walking here, because then you can really see how you can start affecting stuff in 3D space and visualize it also for interactive installations. But you guys have the webcam, so you can try it. Any questions do you have, or no? Yeah. Okay. So the one thing I had to do was to say full image, and instead of having the 0 and 1, actually pixels. This doesn't matter much, but here you just do sequence channel per name, and then because what it does, it names the channels by row. So if you do that, it would take all the rows red, all the rows green, and it would put them into one channel, which correlates to what we've done here with the grid, so it matches. Make sense? Okay, I can definitely check it out. Something else I wanted to tell you guys is that building this and watching it in 3D is fine, but something that I think that's very, very valuable is to watch this in context, which what I mean by that is, okay, now we have some nice interactive geometry, but we want to see it in a room where we can walk around it and affect it. So usually what I do is that I build another component that's called visualization. And this thing is going to be our visualizer for our scene. so basically we can definitely like take that geometry and build like a small, if you had like a architecture, so you'll get the model from them of the space you're building at. But for now, I'm just gonna create like a box, like a room, a small room. And same like we did before with the ArcBall camera, I'm gonna do here. So I want to go to my viz, and here I'm going to put a null. And I'm going to delete one of these faces. Let's see. Yeah, I deleted this one. So that's going to be our room. Let's make it a bit bigger. 2. There you go. And then we want to be able to render it with an ArcBall camera again. Or if you were in VR, so you would actually render it to the VR. And I'm going to put my render result as my background to the ArcBall camera. And go to my viz panel view. There you go. And render our room. Oh, okay, ArcBall camera. And what's happening? Oh, okay. So I have to assign the camera, obviously. Cool. And then we want to have our screen that's going to display our interactive installation. So let's just, what we can do is we can take our grid from here, actually. Take the grid from here. Okay. Let's just do this. And place it in our room. Also, I need a light, so you can see that. And the light should be inside the room. There you go. Right. Cool. And our grid is going to display our content. So let's put a geometry chop, geometry comp, and a constant. There you go. And here, it's the other way around. I want it to be on the other wall here. And I want it to place my screen there. Just position it on the wall. And then what's going to happen is that basically while you work on developing the interactive content, you can either display, render it here and display it in the visualization, or just display the full 3D geometry in the visualization. So you could walk around the room and interact with it before you go and execute it. So the classical one would be just to render it here. render it here using that and a camera. There you go. And my camera. Okay, so I need to make that. There you go. Cool. So that would be our final output. And then this thing could get like, so I'm gonna call this null out. And something cool is that I can give it a global shortcut and call this scene, which I always do. And then we could reference this in our texture by just like putting a select top here and selecting our output. Select top. Just select. Select. What? Yeah, I got it. And something very useful about those global op I've been mentioning is that basically this thing, it could live here, but it could also live inside this or inside that. And in Touch Designer, you're always referencing stuff. So when you move a component somewhere else, everything breaks. That's why I really recommend using these global op shortcuts. And that way you can just write Python code, say op.scene, which is I call this guy. And that way I already go to the path of that operator. This one, scene. And if I want to look inside, I'm just doing this op, say out, because I called it out. And that way you see, like, wherever I'm in Touch Designer, when I reference op scene, it knows where this node's at, and it gives me the full path. So right now, if I take this stuff and I, like, for example, paste it inside here, this reference is still working. That's why I recommend using those all over the place, wherever you can, and just use op global shortcuts, and then you can look inside and search for your node. And then this thing is going to be our texture, and that way we can visualize our interactive installation by being in that space and working on it. So we can keep working on it and refining it, but we kind of see it in context and not working on the final result as a canvas, but you visualize it as you build it. And I really find that super useful in my work, day-to-day work, because really it gives you a perspective of how big it's going to be, you know, how fast it's going to move, how many people could stand in front of it, all kind of like basic stuff that you have to come with and make decision when you build up the content. Instead of just building up the content and then ending up seeing all this stuff, say, oh, I should have took those decisions, now I have to go back and tweak it. Doing like that workflow where you have a visualization component that shows you your final result in context is very, very useful. And that's about it. I think I'm finished showing you everything. So thanks so much for coming. Cheers, guys.